Okay, good. So we're into chapter 11. We're going to talk about data displays. And this is hopefully super comfortable and you're going to feel really good because you've been doing these kinds of things since you were probably in kindergarten. They do statistical stuff in kindergarten. And you've actually used mean, median, mode, and range. You've already used these many times. Because we're in 7th grade, what are we going to see more of? Decimals, negatives, definitely negatives. So we're going to be dealing with our integers. Integers are whole numbers and their opposites, right? So we're going to see negatives. So statistics. Statistics, a way to compare data. So you might, we might compare the heights of all 7th graders by gathering data, gathering the heights of all 7th graders, and then doing various things with it. You know, what is the most common height? What is the mean of the heights? And what is the range of the heights? You know, who's the tallest, who's the smallest type of thing. So we could do that with the heights of all 7th graders. So, short lesson, and we begin with averages. Their averages are, honestly, they are ways to measure the central tendency of the data. Can you say central tendency?
Central tendency.
So where does the data tend to center, right? So the first average is the most common one, and sometimes people will just say, what's your average? And they mean this. And the word begins with M, and it is mean, the first one, mean. So who can tell us how to find the mean of a set of data? Chris?
You add everything up and then divide the total
By what? Did you say by 2? He says you add everything up and then you divide the total by 2. Is it always 2? No? What else might it be? 3? How do you know what to divide by? Braden? The number of numbers that you added up. Right. Okay, so to find the mean, we take the sum of all the data, all the individual numbers, and then divide by the number of values that were in the data. We're going to do this shortly with some real data. Bless you.
Thank you.
But this is just a quick review first in your little rule box. Median. When I think of the median, do you know where the median is on a freeway? Where is the median on the freeway, Hannah?
It's the middle divider.
The middle divider. Even Encinitas Boulevard. If we come down the hill here and go down Encinitas Boulevard, do you know they didn't used to have that median? That median that has what in it? Have you not noticed? When you go down the hill to the intersection of Encinitas and El Camino Real. Okay, I'm thinking of El Camino Real. Sorry, I said Encinitas. El Camino Real, on your way to Target and Home Depot. Have you noticed the median?
Yeah.
And what is in it?
Plants.
Beautiful plants and trees. It's really beautiful. There's even one of those lamppost type things that represents the historic
Bless you.
El Camino Real. Have you seen that? When you're driving down near Target, there's one, you know, in the median. So median means in the middle or in the center. So on freeways, they sometimes they design those to steer cars back onto the same direction they were traveling in case you were to hit the median. They're engineered so that the wheels are steered back into the flow of the direction you were heading so that you don't go over and hit head on into somebody in the opposite flow, right? Median. It's the middle value. So we're going to have to order our values least to greatest in order to find the middle value. Now, what happens when you have, let me just do a quick sample of this one. You don't have to write it down, let's just think about this. If I have numbers 1, 2, 3, 4, and 5, they are in order least to greatest, right? So what is the median? 3, 2, 1, 3. The median is one smack in the middle. What if I have this stuff? 6. What does 1 do? Charlie? Take the 2 middle numbers right here and divide them by what? You actually have to not just divide them, you have to do something first. Add them, right? And then divide by what? There's where we divide by 2 because there are 2 numbers, right? And so what is the median for this set? 3.5, which isn't even a number in the set of data, which is possible. It's possible that you can have a median that is not in the set of data. Is it possible you can have a mean that is not in the set of data? Yes, of course. I mean, think about batting averages. Does anybody know your batting average? Does anyone here play baseball?
I used to.
What's your batting average? Or what has it been? Give me an example of your batting average.
I think it was like
Eight on the dot, 800?
I don't know. I hit like a 260.
If it was 8, that means every time you come to bat, you hit 8 times. Each time you come to bat, you hit 8 times. You get a hit. Is that possible to come to bat once and hit 8 times?
No, it means like you get.
No, like out of
No,
8 out of 10.
the perfect batting average would be what number? 1. So if you have a batting average of 8, do you realize you come to bat and you hit 8 hits in the one at bat? Is that possible?
I ran like
Oh, 0.8, 0.8. He now says his average might be 0.8, which is 0.88 tenths, 80%. 80%. So that means when he comes to bat, out of 10 times, how many times is he going to get on base? 8 times. That is a unbelievable batting average, 80%, 0.8.
That is
Unbelievable. But that can happen in Little League,
the major leagues.
in pony leagues. Does it happen in...
250.
No, right, does it ever happen in the major leagues?
It's like
No,
200.
250 is an awesome batting average. And when we convert that to a percent, what is 0.25 as a percent? 25%. So you are an incredible Major League Baseball player if you go to bat and out of every 4 at-bats you hit once, you get on base once. Do you hear? Well, actually there's an on-base percentage too. They do so many statistics for baseball. It's really fun. It's a good way to learn your statistics. But anyway, okay, so these two, mean and median, you could have an average that is not even a number that was in the data. I mean, can you go to bat and hit 8 tenths of a time at your at bat? Is that possible to hit an 8 tenths of a hit? Can I have 8 tenths of a hit? No, you either are hitting or not hitting. It is very black or white when you go to the plate. But when you take a bunch of times at the plate, now you can have a 80% average or whatever. You know, Tony Gwynn almost got the historic record, which is held by who? No, the historic record. Let me pause the video. Okay, so this definition says middle value when the values are least to greatest, and if you have an even number of values, then the median is the mean of those two in the middle. Take the mean, add them, divide by 2, and you'll have it. Our final average is called the mode. I love this word mode. It reminds me of having pie a la mode. What does it mean if you have pie a la mode? Emily? With ice cream. And when you have ice cream, you don't just want a little, you want a lot. That is the case with this word, mode. You want a lot. Or it's telling you what? The mode of the data is telling you, who knows? Which number does what? Happens, say it, Ryan? Occurs the most, okay? So in this little set of data that I gave you here, is there any number that occurs more than any other? No, but if I gave you one more piece of data, like I said, 2. Now what's the mode of that set? 2, because that one occurred twice, okay? What if I gave you another piece of data for this set and I said 6? Now we have 6, 1, 2, 3, 4, 5, 6, 2. So now what's the mode now? Good, 2 and 6. You can have 2 modes. Like you can have 2 scoops of ice cream. Okay. So mode, value that occurs most often. So the question is, can there be no mode? And the answer is, yes, it's a very sad day when you have no mode. No ice cream. No. So if I have that original set of data, 1, 2, 3, 4, 5. There's no mode. No mode. So you just say there's no mode. Okay. Range. The range of the data. So when I think of range, I think of home on the range. where the deer and the antelope play. When you picture that, is that your favorite song, Brayden? When you picture, oh, you have it on your iPod? Oh, that's cool. I should get that for this video. Anyway, when you picture that in your mind, the range, you think of like Bambi, where Bambi was with his mother out on the range. It was so sad. So, what does that look like in your mind? What does that look like?
A field.
It looks like a field or a meadow. And on that boundaries there are what? Trees. Don't you feel the trees and the river running through over near the trees? Right? So you're looking at an expanse. The range is an expanse, right? So how do we find that in math with a set of data? Hannah?
Isn't the difference between the highest and lowest?
Yes, you know it is. Okay, you've done this before. Good. Difference between the greatest and least. So you're trying to find out how wide is this set of data. Just subtract the smallest from the largest number, and you'll see how wide it is. So if we go back to this set of data that we had, which is a mess, we have anything from 1 to 6. So we could say the range of that data is 5. Good. 6 minus 1. This last word of the day is super fun, outlier. Outlier. I love this word. So if you are the outlier, you are unique, right? Let's see, let's imagine, how could we find an outlier in this community? How about, this community? The seventh grade, your heights. How tall are you, Bianca? How tall are you?
4'11".
5.
You're 5 foot?
4.
4, 3, 2, 1.
Okay,
That's only 40 inches shorter than
She's 4'11".
She says 5 foot.
4'11.
She thinks 4'11". Okay, we say 4'11". Whoops, that's bad. 4 foot 11 inches. Okay, do we have other heights? Max, how tall are you? I'm going to pause the video and get some heights here. Okay, so we are discussing outlier, and in our set here, which number seems to be the outlier? It doesn't seem that extreme here. Ryan, shh. It would be maybe the 4 foot 11 or maybe the 6 foot 5, right? The outlier is a value much greater or much less. Usually it's not hard to see. Look at this set of data. I bet in 1 second you can tell me the outlier. Ready? When you see it, say it. Ready?
1,000.
There it is, 1,000. It's so extremely different. It's like the outlaw. The outlaw. So different from the rest. Okay? Let's try this. I'm going to give you a set of data. You are going to find the range and the mean, median, mode of this set. Now, I should have added a few negatives in. In your assignment today, you'll have some negatives, of course, because it's 7th grade. Okay? So go ahead and do what you need to do, and we'll come back and check out your answer. Okay, we added the values of all the data and divided by 9 and got 17. So there's our mean. Now, the median is the middle, but we must order the data first. So here's a strategy for doing it. What's the smallest value? 10. So we're going to make a list. 10. As we go, we either cross off or we check off the data. On your assignment today, write the list down and then do it on your paper. Please try not to write in the book. Okay? 10. What's the next smallest? And the next. And the next. And. And we got them all. If you're checking them off, your accounting is organized and you have them. Okay, I'm going to have to pause the video. Find the median. Because there are 9 values in this set, you simply had to say 9 divided by 2 is 4.5. 4.5 rounds to 5. So the middle data is 1, 2, 3, 4, the 5th one, right? 17, which matches perfectly with our mean, which is nice. The mean and median don't always match perfectly. Okay, how about the mode? What's the mode? No mode. And then the range is? 14. Good. 24, take away the least value, equals 14. No mode. Okay, and your assignment. There you go.